Dear student, good morning. In this session, we are going to discussing the new chapter, Binomial Theorem. So it is very important chapter for IP and also JEE Main. So many questions related to these concepts. These are very useful in IIT JEE Main examinations also. And there are two essay questions and one 2-mark question from this chapter in IP examinations. Okay, so be seriously listen and understood. Okay, let us start. Okay, so the binomial theorem. Now we are discussing the introduction. So what is the binomial theorem? So what is binomial? Bi means two. Okay. Now we are the expansion of the two terms. That is, we have taken a plus b. We have taken a plus b. These are the two terms here. A plus b. The integral index. Here the binomial theorem for positive integral indices. So the powers are integers that taken. This is suppose a plus b whole power 0. Here index is 0. Here these are the two terms a plus b. We know that a plus b whole to the power of 0. That is anything power 0 is 1. That is value a plus b whole power 0, that is value is 1. See that a plus b whole power 1, a plus b whole to the power of 1. That is the expansion is here a plus b. Okay, that is a quotient is 1 and b quotient is also 1. Next we are writing the a plus b whole square. That is the well-known formula. A plus b whole square is equal to, that is a square plus 2ab plus b square. This is the expansion of the a plus b whole square. Here a quotient is, a square quotient is 1 and AB quotient is 2 and B square quotient is 1. Next we are writing the A plus B whole cube. This is also well-known formula. So what is A plus B whole cube? That is A cube plus 3A square B plus 3A B square plus B cube. This is the formula a plus b whole cube. After that, we are writing a plus b whole to the power of 4. A plus b whole to the power of 4. Now this can be written as a plus b into a plus b whole cube. A plus b whole cube. We are writing a plus b whole cube. This is the formula, and multiplying with a plus b. Then we are getting the a plus b whole power 4. So up to a plus b whole cube we are familiar. But these formulas a plus b whole power 5 and a plus b whole power 5 and a plus b whole power 6 and so on. We are not familiar formulas for us. Okay, now what is the value expansion of a plus b whole power n? A plus b whole power n. So we are observing this series here a plus b whole power 0. Then we are only one term, that is 1. Okay, now that is 1. Okay. Now we are writing a plus b whole power 1, that is a plus b. Here the quotient of a is 1 and quotient of b is also 1. Okay, now we are writing here 1, 1. Okay, now we are adding these two, that is 1 plus 1, that is 2. Then we are writing 1 before and after, then we are 1, 2, 1. Then a plus b whole square. In this expansion, a square quotient is 1 and ab quotient is 2 and b square quotient is also 1. Next, we are writing this, adding 1 and 2, that is 3. Here also adding 2 and 1, we are getting 3. We are writing 1 before and after. Then these are the quotients 1, 3, 3, 1. Okay, here a plus b whole cube expansion, that is a cube quotient is 1. Next term a square b quotient is 3 and also a b square quotient is 3. Then the last term b cube quotient is 1, that is 1, 3, 1. 1, 3, 3, 1. Okay, next what is the expansion of a plus b whole to the power of 4? So we are multiplying these, we are writing like this manner. So what is their observations? See that here a plus b whole power 1, that is a plus b. Here a plus b whole square. Observe this expansion. Here the first term is a and the second term is b. So here the first term is the index of the power. Okay, that is 2. Highest power is 2. Next, what is here b power 0. Next, the quotient is 2. The first term, that is decreasing. 2 minus 1, that is 1. And b power is increasing, that is b power 1. The last term here b power is increasing, that is b square. A power is 0. We are observing this series a plus b whole square in this expansion. So the first term powers are decreasing and the second term powers are decreasing and the second term powers are increasing. Okay, now we are writing the a plus b whole to the power of 4. This expansion, the quotients are like this. So we are adding these two, then that is 3 plus 1, that is 4, that is 3 plus 3, that is 6. Next 3 plus 1, that is 4. Now write 1 before and after. These are the quotients 1, 4, 6, 4, 1. We are writing a plus b whole to the power of 4. These are the quotients. What is the first term? That is a to the power of 4. Highest power, that is index is here 4. So now we are writing the quotient of a to the power of 4 is 1. Next, we are writing the quotient is 4. The quotient is 4 and first term is power is decreasing, that is a cube, and second term power is increasing. Here b power 0, here b power 1. Next, we are writing the quotient is 6. Next, first term power is decreasing. Here a cube, then here we are getting a square, and second term power is increasing. Here a power b power 1, here b square. Next term quotient is 4, that is 4, and a, that is first term power is decreasing by 1, that is 2 minus 1, 1, and b term, second term b power is increasing. Here b square, here we are getting b cube. Next, last term quotient is 1. This first term quotient is 0 and second term is highest index, that is b power 4. So this is the expansion of a plus b whole to the power of 4. Okay, so this is the a plus b whole to the power of 4. Expansion is this one. Like this manner, we are writing a plus b whole to the power of n. So we know that this is in the previous classes you have learned this is the partial triangle. For this partial triangle we are writing the quotients here. Okay, so now we are writing in this expansion of a plus b whole to the power of n, we are taken the coefficients are binomial coefficients. We have taken the binomial coefficients that are NC naught. The quotient is NC naught. The first term is A to the power of index that is n. NC naught A to the power of n. The second term power is 0. The second term power is 0. Next NC1 A to the power of n minus 1 B to the power of 1. Next NC2 A to the power of n minus 2 B square, and so on. NCR A to the power of n minus r into B to the power of r, plus so on. The last term is NCN A power 0 B to the power of n. This is the expansion of A plus B whole to the power of n. So now we are writing like this. These are the coefficients we are taken NC naught, NC1, NC2 and so NCR and so on NCN. These are the coefficients. We are called, these are the coefficients of binomial coefficients. These are all NC naught, NC1, NC2 and so on NCN. These are all called binomial coefficients. Okay, so these are the expansions. We are knowing well-known formulas: a plus b whole power n, a plus b whole square, a plus b whole cube. Then after a plus b whole to the power of 4 and a plus b whole to the power of 5 and so on, a plus b whole to the power of n. These are the expansions we are discussing like this manner. These are the coefficients, and the first term powers are decreasing and the second term powers are increasing here. Now the expansion of a plus b whole power n is NC naught A power n B power 0, NC1 A power n minus 1 B power 1, NC2 A power n minus 2 B square and so on. NCR A to the power of n minus r B to the power of r plus so on. NCN A to the power of 0 and B to the power of n. Okay, now before going to the binomial theorem, we are well-known formulas. I am recalling the formulas. So in the permutation combinations chapter, you learn some formulas. These are useful in this chapter also. What is see the note here. The first one is, what is the n factorial? What is the n factorial? Represented by n factorial. These are, we are simply right here n factorial like this. This is the notation is n factorial is represented by like this or like this. That is n factorial. What is the n factorial? N factorial is the product of n natural numbers. Product of n natural numbers. That is, this can be written as n into n minus 1, n minus 2, n minus 3 and so on, 3 into 2 into 1. Or we are writing also from left to right. Okay, 1, 2, 3, 4 and so on, product of n natural numbers. So n factorial is this one. Now it is also can be written as n into n minus 1. After from this we are writing the n minus 2 factorial. Okay, these are like that. Okay, n factorial is n into n minus 1, n minus 2 and so on, 3 into 2 into 1. That is product of n natural numbers. We are observing, this is the formula we are knowing. N factorial is the product of n natural numbers. We are observing that is 0 factorial. What is 0 factorial value is 1. 0 factorial value is 1. And also NC naught. What is NC naught value is also 1. That is the first binomial quotient. And also NCN. NCN is value is also 1. We know the formula NCR. What is the NCR? NCR is the formula n factorial by n minus r factorial into r factorial. So this is the known formula we are learned in the this proof is also in this chapter permutation combinations. What is NCR? We are taken R things, we are selecting R things from n different objectives. So that is NCR is the formula n factorial by n minus r factorial into r factorial. From that we are getting these results. NC naught value is 1 and NCN value is also 1 and 0 factorial value is also 1. And we must know some other formulas. What is NCR plus NCR minus 1? You know the formula NCR plus NCR minus 1, that is n plus 1, that is n plus 1 CR. It is very useful in this binomial theorem. NCR plus NCR minus 1 is equal to n plus 1 CR. And another formula, that is NCR by NCR minus 1. NCR by NCR minus 1 is the formula n minus r plus 1 by r. This is the formula NCR by NCR minus 1, that is equal to n minus r plus 1 by r. These are the formulas very useful in the binomial theorem. So we must knowing these formulas. Okay, the theorem. This is the binomial theorem. Now we can prove this theorem by mathematical induction. Here the statement is let n be a positive integer and x comma a be real numbers, then the expansion of x plus a whole power n is nc naught x to the power of n into a to the power of 0 plus nc1 x to the power of n minus 1 into a to the power of 1 plus nc2 x to the power of n minus 2 into a square plus so on NCR x to the power of n minus r into a to the power of r plus so on NCN x to the power of 0 into a to the power of n. This is the statement. See the proof. This is the proof. We can prove this theorem. We can prove this theorem by principle of mathematical induction. Let we have taken the statement is let P of n be the statement, that is x plus a whole to the power of n, that is equal to the expansion here nc naught x to the power of n a to the power of 0, that is the first term power is n and the second term power is 0. Next plus nc1 x to the power of n minus 1 a to the power of 1 plus nc2 x to the power of n minus 2 a square plus so on ncr x to the power of n minus r into a to the power of r plus so on ncn x to the power of 0 a to the power of n. This is the our statement, that is say P of n. P of n be the statement, that is x plus a whole to the power of n is equal to nc naught x to the power of n into a to the power of 0 plus nc1 x to the power of n minus 1 a power 1 plus nc2 x to the power of n minus 2 a square and so on ncr x to the power of n minus r into a to the power of r plus so on ncn x to the power of 0 into a to the power of n. This is the our statement. Now we can prove this theorem by mathematical induction. So in the first step we have to take and put n is equal to 1. We are proving the statement is to for n is equal to 1. So put n is equal to 1. Then the statement is x plus a to the power of 1. That can be written as in the form of nc naught x power n a power 0, nc1 x power n minus 1 a power 1. Here what is n? 1 is equal to 1. Here 1 c naught into x to the power of 1 into a to the power of 0. This is nothing but 1 c naught, that is 1, x to the power of 1, that is x, a to the power of 0, that is 1. So this term is x. Here we are getting x. Plus the next term is nc1, that is 1c1 into x to the power of 1 minus 1 into a to the power of 1. We are observing what is the value of x plus a whole power and expansion is x plus a. That x plus a, we are writing here 1c naught x to the power of 1 into a power 0 plus 1c1 x to the power of 1 minus 1, that is x power 0, that is 1 into a to the power of n, that is nothing but x plus c. So this is true for n is equal to 1. The statement is true for n is equal to 1. Therefore, P of n will be true for n is equal to 1. Now we are proving for n is equal to 1. The statement is true. Assuming that, next step is assuming that P of n be the true for n is equal to k. Now assuming that statement P of n be the true for n is equal to k. The statement is true for n is equal to k. That is we are getting what is the statement P of n is true for n is equal to k. For n is equal to k, we are having the statement that is x plus a whole to the power of k. Here n is equal to k. Now we are writing in this expansion replace n by k. Then we are writing x plus a whole power k is equal to kc naught x to the power of k into a power 0 plus kc1 x to the power of k minus 1 into a to the power of 1 plus kc2 x to the power of k minus 2 into a square plus so on kcr x to the power of k minus r into a to the power of r and so on plus the last term kck x power 0 a power k. This is the statement for n is equal to k. For n is equal to k, the statement is true. Assuming that P of n will be true for n is equal to k. So now this is the statement, that is x plus a whole to the power of k. That expansion is true. Okay. Now we are to proving the statement is true for n is equal to k plus 1. Now we have to prove that. Now we have to prove that the statement P of n will be true for n is equal to k plus 1. Then by principle of mathematical induction, the statement is true for every n belongs to z plus. For every positive integer, the statement is true by mathematical induction. Okay, now we are proving the statement is true. Okay, now we are proving the statement is true for n is equal to k plus 1. Now we are consider x plus a whole to the power of k plus 1. Now we are proving the statement is true for n is equal to k plus 1. Now we are consider this expression x plus a whole to the power of k plus 1. Now we are writing this x plus a whole power k plus 1, that can be written as x plus a into x plus a whole power k. The bases are equal, x plus a, here power is 1, here power is k, that is x plus a whole power k plus 1. Now we are writing this x plus a into this x plus a whole power k, that is true for this expansion. So that is the statement is true for n is equal to k. We are getting this x plus a whole power k can be written as in previous we are writing, that is kc naught x to the power of k a to the power of 0 plus kc1 x to the power of k minus 1 a to the power of 1 plus kc2 x to the power of k minus 2 a power 2 plus so on plus kcr x to the power of k minus r into a to the power of r plus so on kck x to the power of 0 a to the power of k. Here first term powers are decreasing and second term powers a power 0, a power 1, a power 2 and so on a power k. So this is true for n is equal to k. So now we are assuming the statement is true for n is equal to k, then x plus a whole power k can be written as this one. Okay, this is the x plus a whole power k. Now we are multiplying this expression with x plus a. First we are multiplying with x. So we are multiplying each term by x. Then the powers of x is increased 1. Okay, now I am multiplying x. Okay, then here kc naught, where x into x power k, that is x power k plus 1 a power 0 plus kc1 x power k minus 1 plus 1, that is k into a power 1. Next kc2 x power k minus 1 a power 2 and so on kcr x power k minus r plus 1. We are increasing x powers by 1 into a to the power of r plus so on kck x power 1 a power k. Here we are multiplying each term by x. Then the power of x is increased by 1. Here x power k plus 1. Here x power k minus 1 plus 1, that is x power k. Here x power k minus 2 plus 1, that is x power k minus 1 and so on. Here x power 0, we are getting x power 1. Next we are multiplying, next terms are, so plus a, we are multiplying these terms, each term is multiplied by small a. So then the powers of a is increased by 1. Then we are writing here a into each term in this expansion, that is kc naught, here x power k, here a power 0 into a power 1, that is a power 1. Next kc1 x power k minus 1 a power 2, that is increased by 1, that is a power 1 plus 1 a power 2 plus kc2 x power k minus 2 a power 3 and so on k c r x power k minus r into a to the power of r plus 1 plus so on plus k c k x power 0 into a power k plus 1. Now we are multiplying this one by x and a. So multiplying by x we are getting this one and multiplying with a we are getting the second terms. So these are the terms we are multiplying with x plus a. So now we are writing here. Now we are writing first one is as it is, that is k c naught x power k plus 1 a power 0. A power 0. Okay, that is the first term. In the second term, that is kc1 x power k a power 1. Here also kc1 here also x power k into a power 1. Okay, in these two there are common terms x power k a power 1. Here x power k a power 1. These are common terms. So they are common from these two terms x power k into a power 1. Then we are getting here x power k into a power 1. Then the remaining terms are kc naught plus kc1 or kc1 plus kc naught plus kc1. Okay, so these are the kc1. Here kc0 is remaining terms by commoning x power k into a power 1. Then here kc1, here kc0. In this term, in these two terms, x power k minus 1 a square is common. X power k minus 1 a square is common. Then we are getting here kc2 plus kc1. Okay, like this we are common. In the last one we are writing the same as it is, we are writing, that is kck x power 0 into a power k plus 1. So in the middle of first and last terms we are common the terms x power k a power 1 x power k minus 1 a square and so on. Okay, now this can be written as here, that is kc0. That can be also, what is kc0? The value is here kc0 is 1 and also k plus 1 c naught is also 1. This kc0 is value is 1 and also k plus 1 c naught value is also 1. Now we are writing this one k plus 1 c naught x power k plus 1 into a power 0 plus here kc1 plus kc0. You know the formula. This is the formula mcr plus mcr minus 1, that is m plus 1 cr. Using this formula mcr plus mcr minus 1 is n plus 1 cr. Here in the place of n is k, kc1 plus kc0. That can be written as k plus 1 c1. So using this formula, so like this formula mcr plus mcr minus 1 is n plus 1 cr. Now this is kc1 plus kc0. Here n is k and r is 1. K plus 1 is k plus 1 c1. So this is kc0 kc1 plus kc0. That is like mcr plus mcr minus 1. So here is r is 1, r minus 1 is 0. Okay, this can be written as k plus 1 c1 and the remaining terms x power k into a power 1. Next here kc2 plus kc1, that is k plus 1 c2 into x power k minus 1 a power 2 and so on. The last terms kck. Here kck value is 1. Kck value is 1. This is also nothing but k plus 1 c k plus 1. This value is also 1. Now we are writing kck, that can be written as k plus 1 c k plus 1 into x power 0 into a power k plus 1. Okay, we are observing this one x plus a 4 power k plus 1. So this is the expansion x in the place of n is k, here k plus 1. So here k plus 1 c naught x power k plus 1 a power 0. Next k plus 1 c1 x power k, that is first power x power is k plus 1. Then the terms of first term powers are decreasing. Here k plus 1, then here k plus 1 minus 1, that is kx power k, and second term a power 0, here second term a power 1. So second term powers are increasing and first term powers are decreasing. So here k plus 1 c1 x power k a power 1 plus k plus 1 c2 x power k minus 1 into a square and so on, k plus 1 c k plus 1 x power 0 a power k plus 1. So this is like x plus a whole power n expansion. So in the place of n, we are writing here k plus 1. So the statement is true for n is equal to k plus 1. So therefore, the statement P of n is true for n is equal to k plus 1. So the statement is true for n is equal to k plus 1. By principle of mathematical induction, by principle of mathematical induction, by principle of mathematical induction, the statement is true for every n belongs to z plus, that is for every positive integer, the statement is true. So that is the theorem. So we are proving this theorem by principle of mathematical induction. The statement is true for every positive integer of index n. Hence, that is theorem is proved. Hence, the theorem is proved. Okay, so this is the binomial theorem. This binomial theorem we are proving by principle of mathematical induction. Okay. Here the coefficients NC naught, NC1, NC2, NCR and so on, NCN. These are called the binomial coefficients, are called the binomial coefficients, simply denoted by C naught, C1, C2 and so on, CR and so on, Cn. These are binomial coefficients. Now we are representing the binomial expansion, that is the x plus a whole to the power of n in the notation sigma. This expansion is denoted by sigma NCR x to the power of n minus r into a to the power of r, where r is running from 0 to n. This expansion x plus a whole to the power of n, that expansion is in the notation sigma r is equal to 0 to n NCR x to the power of n minus r into a to the power of r. Now here, if you are replacing a by minus a, then x minus a whole to the power of n. See the expansion here, x plus a whole power n is the expansion, this one. So here in the place of a is we are writing minus a. Then the expansion is nc naught x to the power of n a to the power of 0. So anything power 0, that is minus a to the power of 0 is that is nothing but a to the power of 0 is 1. Okay. Next, what is here? NC here minus, we are getting minus NC1 x power n minus 1. Here in the place of a is minus a, we are getting here
nc naught, that is minus nc1 into x power n minus 1 a power 1 plus nc2 x power n minus 2 a power 2. Here in the place of a is minus a whole square is nothing but a plus a square. So these are the term minus and so on. Here the general term, so that is minus 1 to the power of r ncr x to the power of n minus r a to the power of r plus so on plus ncn into a to the power of here n. In the e place also we are writing minus 1 power n into ncn a to the power of n. So if f is even, then here getting plus, and if n is odd, here the last term is minus ncn. Okay, this is the expansion of x minus a whole power n. This is also can be representing in the sigma notation. Sigma r is equal to 0 to n minus 1 to the power of r ncr x to the power of n minus r into a to the power of r. So this is the expansion of x plus a whole power n is sigma ncr x power n minus r a to the power of r. The expansion of x minus a whole power n, here we are getting plus minus in alternatively the series. This expansion is denoted by sigma r is equal to 0 to n minus 1 to the power of r ncr x to the power of n minus r into a to the power of r. So these are the expansions of x plus a whole power n and x minus a whole power n. Next, what is the standard binomial expansion? See that the standard binomial expansion expression or expansion. Standard binomial expansion, that is we have taken 1 plus x whole power n is equal to, this is the standard binomial expansion, that is the expression is 1 plus x whole to the power of n. So this expansion is nc naught, the first term to the power of n, 1 to the power of n, that is 1 into the second term power 0, the second term power 0. So that is here 1 to the power of n into second term power 0. That is the binomial expansion. So 1 plus x whole power n is we are taken standard binomial expression, that is 1 plus x whole power n. This expansion is nc naught 1 to the power of n, the second term x to the power of 0. Next nc1 1 to the power of n minus 1 x to the power of 1 plus nc2 1 to the power of n minus 2 x to the power of 2 and so on. Last term is ncn 1 to the power of n into x to the power of n into x to the power of n. So this is the standard binomial expansion. Okay, so that is nothing but we are writing 1 plus x whole power n is equal to, that is nc naught, here x power 0 is 1, 1 power anything is 1, plus nc1 x, nc2 x square, nc3 x cube and so on and so on. Here the middle term in r plus 1 term, that is ncr x to the power of r plus and so on ncn x to the power of n. This is the standard binomial expression. We are taken, this one is this equation is say equation 1. So this is the standard binomial expression. So the expansion is nc naught, nc1x, nc2x square and so on ncr x power r and so on ncn x to the power of n. This is the standard binomial expression. Okay, now we are taken, put x is equal to 1, put x is equal to 1 in this expansion, in this expansion, then we are getting here 1 plus, in the place of x we are substituting x is equal to 1, 1 plus 1 whole to the power of n, that is equal to nc naught plus nc1. Here in the place of x is 1 plus nc2 1 square plus nc3 1 cube and so on. Here nc are 1 to the power of r and so on plus ncn 1 to the power of n. So that can be written as here 1 plus 1, that is 2 to the power of n, that is equal to nc naught plus nc1 plus nc2 plus nc3 and so on, last term ncn. So this is the sum of the binomial coefficients. So here nc naught, nc1, nc2, this can be simply denoted, nc naught is c naught, nc1 is c1, nc2 is c2, c3 and so on cn. So here we are observing the sum of the binomial coefficients, c naught plus c1 plus c2 and so on cn is equal to 2 to the power of n. That is the sum of the binomial coefficients. Sum of the binomial coefficients is equal to 2 to the power of n. So this is the one of the property we must learn. So this is the property c naught plus c1 plus c2 and so on cn. Sum of binomial coefficients is equal to 2 to the power of n. Now we have to substitute, put x is equal to minus 1 in equation 1. So this is equation 2. This is equation 2. Now we have to substitute x is equal to 1 in this expansion. 1 plus x whole power n. In this expansion we are writing in the place of x is minus 1. Then we are getting here 1 plus 1, here in the place of x we are writing minus 1. 1 minus 1 whole power n is equal to nc naught. Here in the place of x is minus 1, we are getting here minus nc1. Okay. Next, in the place of x we are writing minus 1. Minus 1 whole square is plus 1. We are getting nc2 minus nc3 like that and so on. In the last term we are getting minus 1 power n ncn. Minus 1 power n ncn. So here what is 1 minus 1? That is 0. 0 power n is 0. This will become 0. Next here nc naught, that can be written as c naught minus c1 plus c2 minus c3 and so on. Here minus 1 power n cn. Okay. Now these are the terms c naught minus c1 plus c2 minus c3 and so on. So the terms of all coefficients c1, c3 and c5 all are before negative. So these negative terms moving to other side. Then we are getting here c0 plus c2 plus c4. These are even suffixes. So is equal to, we are getting c1 here odd suffix c1 plus c3. This c1 c3 are moving to other side. Then we are getting positives. So c1 plus c3 plus c5 and so on. Okay. So the sum of the coefficients c0 plus c2 plus c4 and so on equal to c1 plus c3 c5 and so on. Here these are values equal to 0. Okay, these are equal to 0. So, sorry, so these are equal. Both of these two are equal. So, sum of these terms, so C0 plus C2, C4 and so on is equal to C1 plus C3, C5 and so on. We are moving to these terms in this side. We are getting these sum of the coefficients is sum of the coefficients of even suffixes is equal to the sum of the coefficients of odd suffixes, that is C0 plus C2 plus C4 and so on, C1 plus C3 plus C5 and so on. Both are equal. Okay. Now what is the sum of the coefficients here? Sum of the coefficients C0 plus C1 plus C2 and so on Cn. So sum of all coefficients is 2 power n. So C0 plus C2 and so on is nothing but C1 plus C3 and so on. Okay. So what is the sum of the coefficients of C0 plus C2, C4 and so on? That is nothing but 2 to the power of n minus 1. Okay. Now we are discussing later that one. So now we are saying this is the equation. Now we are taken, this is the equation. This is the equation 3. Now we are taken, this is the equation 3. So equation 2 is the sum of all coefficients C0 plus C1, C2 and so on Cn, that is equal to the power of n. Here the equation 3 is C0 minus C1 plus C2 minus C3 and so on minus 1 power n Cn is equal to 0. Now we are adding these two terms. Now we are adding these two terms. Okay. Now we are adding equation 2 and equation 3. Now we are adding equation 2 and 3. Okay. What is equation 2? That is sum of all binomial coefficients C0 plus C1 plus C2 and so on Cn, that is equal to 2 to the power of n. Sum of all binomial coefficients that is 2 to the power of n. What is equation 3? That is C0 minus C1 plus C2 minus C3 and so on minus 1 power n Cn is equal to 0. So substitute x is equal to 1, we are getting equation 2 in the standard binomial expansion. Substitute x is equal to minus 1, then we are getting this result C0 minus C1 plus C2 minus C3 and so on minus 1 power n Cn. Now we are adding these two equations. Now we are adding these two equations. What is here C0 to C0, that is 2 C0. So C1 minus C1 plus C1 is cancelled. Here we are getting 2 C2. Here plus C3 minus C3 will be cancelled. We are getting 2 here C0, C2, C4 and so on. This will be on Cn here. We are getting here if on the depend of n is negative or positive. Okay, so the sum is 2 to the power of n plus 0, that is 2 to the power of n. So we are common 2 on in all terms, that is 2 into C0 plus C2, C4 and so on, that is equal to 2 to the power of n. Therefore, we are writing here C0 plus C2 plus C4 and so on is equal to 2 to the power of n by 2, that is 2 to the power of n minus 1. So therefore, this is the result of C0 plus C2, C4 and so on, that is equal to 2 to the power of n minus 1. This is the result. It is also important result, that is sum of the coefficients of C0 plus C2 plus C4 and so on equal to 2 to the power of n minus 1. Okay, since here now we are adding this one, we are subtracting 2 and 3, then we are getting another result, that is we are subtracting these two equations C0 plus C1 plus C2 plus C3 and so on. Cn is equal to 2 to the power of n. So what is here equation 3? C0 minus C1 plus C2 minus C3 and so on minus 1 power n Cn is equal to 0. Now we are subtracting these two equations. Now we are subtracting these two equations. Then the signs are changes. Okay. So these are minus. Okay. Now we are subtracting here plus C naught minus C naught. These will be cancelled. Here C1 minus or minus plus C1. That is 2C1. Here C2 will be cancelled. Here 2C3 and next term 2C5 and so on. Okay, the last term is depending on even or odd. So and so on is equal to 2 to the power of n. So in the LHS 2 is common, then we are getting C1 plus C3, C5 and so on is equal to 2 to the power of n. From that we are writing C1, C3, C5 and so on equal to 2 to the power of n minus 1. This 2 is moving to that side, 2 to the power of n by 2, that is 2 to the power of n minus 1. So this is the another result. This is another result. Okay, this is the sum of the coefficients of C1, C3, C5 and so on. That the sum of the series is 2 to the power of n minus 1. So we are observing these are the results. So what are the results? Sum of the coefficients C0 plus C2 plus C0, C1, C2, C3 and so on. Sum of all binomial coefficients is 2 to the power of n, and what is sum of even suffix C0 plus C2, C4 and so on. This is equal to C1, C3, C5 and so on. Both are these are equal to, that is 2 to the power of n minus 1. That is 2 to the power of n minus 1. These three results are very useful in the coming problems. Okay. Okay. Next, see the what are the middle terms in the expansion of x plus a whole power n? What are the middle terms in the expansion of x plus a whole to the power of n? So what are they here? See that the middle terms okay, see the middle terms. The middle terms in the expansion of x plus a whole to the power of n, or what are the middle terms in the expansion of x plus a whole to the power of n? What are the middle terms in this expansion? Now we are seeing the expansion x plus a whole power n. In that, what are the middle terms? So these are in that there are two cases. Case 1, this is the case 1. If n is even number, if n is even number, if n is even number, x plus a whole to the power of n, here index is even number, then what are the middle terms? That is t n by 2 plus 1 is only one middle term. Only one middle term. So this is the formula for the finding the middle term. If n is even number, the index is even number, then the middle term is t n by 2 plus 1. That is the general term t r plus 1. Here r is taken n by 2. So t n by 2 plus 1 is the middle term. The second case is if n is odd number, if n is odd number, then there are two middle terms. Then there are two middle terms, t n plus 1 by 2, t n plus 3 by 2 are the middle terms. Are the middle terms. There are two middle terms. These are one is t n plus 1 by 2 and another is t n plus 3 by 2. These are the two middle terms if index n is odd number. So see the example here. Suppose x plus a whole power, that is 4, suppose 4. So what is the expansion of this expansion? That is 4c naught x power 4 plus 4c1 x power 3 a power 1 4c2 x square into a square plus 4c3 x power 1 x power 1 a power 3 and 4c4 x power 0 a to the power of 4. This is the expansion of x plus a whole power 4. So in this expansion, what are the middle terms? What are the middle terms? In this expansion, the number of terms is 5. In this, the number of terms is 5. What is the middle term? Here 4c2. In that, these are 2 terms. These are the 2 terms. So before 2 terms, after 2 terms. So this is the middle term. This is the middle term. If n is even, the number of terms is odd. If n is even, the number of terms is odd. In the odd number of terms, only we are getting one middle term. So that is 4c2 x square into a square. So here that is the term is obtaining. What is here? N is even. Then what is the formula? T n by 2 plus 1 is the middle term. Here what is n? N is 4. 4 by 2. 4 by 2 plus 1. That is t 2 plus 1. That is t3. That is the third term is the middle term. This is the first term. This is the second term. This is the third term. So that third term is the middle term in this expansion. So in the x plus a whole power 4, so here 4 is even term, even number, then we are getting only one middle term, that is t3 is the middle term by using this formula t n by 2 plus 1. So t n by 2 plus 1 term is the middle term. Okay, so see the another example. If x plus a whole to the power of 5. Here n is the odd number. Here 5 is the odd number. So what is the expansion of this series? That is 5c naught x to the power of 5, 5c1 x to the power of 4 into a to the power of 1 plus 5c2 x to the power of 3 a to the power of 2, 5c3 x to the power of 2 a to the power of 3, 5c4 x power 1 a power 4, 5c5 x power 0 a to the power of 5. This is the expansion of x plus a whole power 5. This is the expansion of x plus a whole power 5. So in this expansion, what are the number of terms? Number of terms is 6. Here 5c1 to 5c5. These are 5 terms and 5c naught. These are 6 terms. In that expansion, there are 6 terms. That is the even number of terms. Here we are getting even number of terms. In that there are 2 terms are middle terms. These 2 are middle terms. So these are the 2 after 2 terms. So middle terms are we are getting 2 terms. This is 5c2 x cube into a square, 5c3 x square into a cube. We are getting 2 middle terms if n is odd number. See that we are saying the formulas. What is middle terms? That is t n plus 1 by 2. That is here t n. What is n? 5. 5 plus 1. 5 plus 1 by 2. That is t 6 by 2. That is 6 by 2. That is 3. That is the third term is one middle term, and another is t n plus 3 by 2. T n plus 3 by 2. That is another middle term. So that is t. Here n is 5. 5 plus 3 by 2. That is 5 plus 3, 8 by 2. That is 4. We are getting T3 and T4. These are the two middle terms in this expansion of x plus a whole to the power of 5. So if index is odd number, then we are getting two middle terms, that is t n plus 1 by 2 and t n plus 3 by 2. If n is even, if n is index is even, that is here x plus a whole power 4. 4 is even, then what is the middle term? T n by 2 plus 1 is only one middle term in this expansion. Okay, these are the middle terms of the expansion of x plus a whole power n. Okay. Okay. See that the another concept. What is the largest binomial coefficient? What is the largest binomial coefficients? Largest binomial coefficient. What is the largest binomial coefficient? What are the binomial coefficients? These are NC0, NC1, NC2, NC3, NC3 and so on, NCR, NCR and so on, NCN. These are the binomial coefficient. What are the largest binomial coefficient? So what are the expansion? These are the coefficients in the expansion. So what are the binomial? The largest binomial coefficient in the expansion. In the expansion of x plus a whole power n. In the expansion of x plus a whole power n, the largest binomial coefficient So how to find the largest binomial coefficient? So these are binomial coefficients. Which one is the largest binomial coefficient? We have to find which one is the largest binomial coefficient. In that there are two cases. The first case is if n is even. If in the index x plus a whole power n, here n is even. If the first case is if n is even number. If n is even number, then the largest binomial coefficient. Then the largest binomial coefficient is NC n by 2. The largest binomial coefficient in that expansion is NC n by 2. This is the only one largest binomial coefficients. These are all binomial coefficients. NC0, NC1, NC2, NC3 and so on, NCn. These are binomial coefficients. If n is even number, then the largest binomial coefficient is NC n by 2. This is the largest binomial coefficient. The second case, if n is odd number, then the largest binomial coefficients, then the largest binomial quotients, or there are two binomial coefficients. These are n c n minus 1 by 2 and n c n plus 1 by 2. These are the two binomial coefficients we are getting. So one is nc n minus 1 by 2, nc n plus 1 by 2. These are binomial, largest binomial coefficients in that expansion. So what is the expansion? X plus a whole to the power of n. In that expansion, so if n is even, then the largest binomial coefficient is nc n by 2. If n is odd number, then the largest binomial coefficients are, there are two largest binomial coefficients. One is nc n minus 1 by 2, nc n plus 1 by 2. These two are the largest binomial coefficients in the expansion of x plus a whole to the power of n. Okay.